Good day, everyone, and welcome to AI Sana, Trends and Case Studies in Local International Market Model. I'm Elena Sidых with you today, and in today's session, we will focus not on a specific technology or startup, but on the broader structure of the energy innovation market. To help us understand that landscape, I'm very pleased to welcome again David Forsberg, Managing Partner at Accent Energy Ventures. In this conversation, we will look at three things. First, a market map of the key players in the sector and how the ecosystem is structured. Second, the major trends shaping the industry today, from regulation and capital flows to technology shifts. And finally, the gaps and emerging opportunities, especially where AI and entrepreneurship might play an important role. David, thank you for joining us, and let's start with the big picture.
It's a pleasure to be here. I'm excited to chat with you today. So I have a presentation here to kind of go over the market map and talk about really the energy sector and start this conversation with a solid footing of the energy space and what's going on. But one of the things that I did with this presentation for the first time ever was I used AI to generate the images, and it took an entire day. It took far longer than I normally would take on a presentation to get the images to work. I didn't want to make it in orange, but it's in orange, and I used multiple different AI slide generators to kind of do this, and I think it speaks to where AI is today and automation, in that I think the presentation is prettier than it would have been had I not done that, but it actually took a long time to get the presentation to be as coherent as it is now. So I just wanted to bring that up as a use case of something that I'm trying to use AI for in everyday use.
Thank you very
Digital,
much, David, for your
yeah.
effort. Thank
What's
you
that?
very much, David. Thank you very much, David, for your efforts.
Yeah. So I think it's important, and I started here in this slide. Like, what is energy, and how should we think about it? And I want you to think very broadly about energy to start. Energy is at the core of what it means to be human. It is at the core of humanity. It is the bedrock of modern industry. Because of that, and because we have it, or certainly in the West, but among much of the world, we have so much energy that we use that we somewhat take it for granted that lights will turn on, that cars will go, that all of those things, and so we need to kind of step back and say, everything that we do in life really requires some form of energy. If we want to have the capacity to do any work or to produce some kind of change, it takes energy. Even the food that we consume, that's a form of energy, is a way of thinking about it more philosophically. There's a great book that you should at least consider reading or reviewing or looking up to broaden your understanding of really what energy is, and it's called Energy and Civilization, and it's written by a guy named Smil, S-M-I-L. My warning to you is that Smil hasn't written an exciting sentence in any of his books, so they are mildly tedious and boring, but they are very, very informative and help to shape the way that we should think about energy. So starting here, energy is pretty much involved in everything we do. And I'm going to talk about one part of energy and the digital trends in the energy sector. So to start, this also creates a framework for thinking about sources and uses of energy. On the left is coal, oil, natural gas, biomass. It makes up probably 80% or 90%, somewhere in that range, of global energy consumption. And then on the right, we have hydropower, nuclear, wind, solar, and probably other. And that makes up a very small amount of the energy we consume. And then in the middle here, we have the energy, how it's used. So a lot of this is used to create like electricity. It's used in transportation, jet fuel, moving ships around, cars. And then it's used for heat, to heat our homes, for industrial processes, and where heat is required. And so these are the three primary uses. And as we go to energy transition, we'll see this slide later on, but this helps us understand the kind of issues and the opportunities that exist in the energy sector as we shift this entire sources and uses of energy. That's what we're really talking about, is shifting this core sector to humanity and everything that we do. We're talking about shifting the left side more to the right side. We're talking about more electrify everything trends. So this is a massive shift and undertaking in the history of humanity. You just cannot, it is difficult to understand the scale of how big this really is. Okay, but we're going to start here with the legacy hydrocarbons. That's, well, coal isn't a hydrocarbon, but oil and gas and coal is what we're going to really start with. It makes up approximately 80 to 90 of global energy consumption. And what are those products? As I said, it is coal, it is oil, and it is natural gas, and then there's some natural gas liquids, which is kind of getting into more detail, but things that like butane that you maybe use for cooking or in other uses that we still burn. And I'm going to start with coal very, very briefly and just talk about it. So if you ask most people, they will tell you that coal consumption is declining. I'm here to tell you that it factually is not. Coal consumption globally is increasing. It is not declining. This fact is somewhat contrary to the commonly understood narrative that we are told in the energy transition that coal is being phased out by solar and wind. If it is being phased out, it's being phased out primarily by natural gas. And that we've seen that in the U.S. consumption numbers. So this brings up an important way to find opportunity just in general in life. I call this from, I'm an investor, so I think of it from an investment perspective, but for an entrepreneur as well, these are where opportunities exist. And I call it mind the gap. And we're going to talk about gaps that exist that create opportunities. That was one of the themes of this talk. And so mind the gap investing or thinking is find areas where commonly held beliefs are incorrect, that the facts don't match up with the narrative being told. Then, once you have identified a gap, figure out how to take advantage of this gap where reality and expectation are mismatched. And that creates a gap in expectations that you can invest in, that you can create companies for, that you can find opportunities. There's a great book that an investor talks about, and it's called Expectation Investing. And it's finding, again, in public markets and other opportunities where the expectations do not align with reality. And coal kind of presents one of those situations. Coal is used for primarily two uses. It is used for generating electricity, power generation. That is the bulk of it. China consumes a huge amount of coal in their power generation. And then industrial applications as well. The manufacturing of steel and cement currently require, in many ways, coal or certain types of coal for the chemical reaction and the industrial heat and process. Okay, I'm going to stop about coal and move on to oil and gas and create kind of that industry framework and map so we can understand how that industry works. The industry is really broken up, and many industries are broken up this way, into upstream, midstream, and downstream. Upstream is the production of oil and gas. Midstream is that kind of transportation of the raw materials. How do you get what was pulled out of the ground to a facility that can then use it? And then downstream is that refining and distribution after it's been refined. And people, I think, don't quite understand that oil and gas has many, many applications beyond just transportation. But it creates gasoline, diesel, jet fuel, LPG, petrochemicals, lubricants. And those petrochemicals and lubricants go into the majority of things that we use in our daily basis. This is this is all kinds of stuff that gets consumed by us as individuals, and we'll talk about that in a little bit. Okay, starting with upstream, this is often viewed as drilling and managing the well. On the left, we have pure exploration and production companies. I selected a few logos. They all tend to be in the U.S. For this example. One, I'm a U.S. focused investor, but two, the real issue is that, or the real difference is between the U.S. market and most international markets is the U.S. is somewhat unique in its structure in that, relative to the rest of the world, in that U.S. Private landowners, so if you own a bunch of land, you also own the minerals below that land. And the minerals are oil and gas. And so that creates, in most of the world, the minerals are owned by the state, the government. And so that creates a dynamic that creates a different marketplace for opportunity for exploration and production companies, and that's, I think, part of the reason why you see so many U.S. onshore different oil and gas companies. There are thousands of them in the U.S. that exist at different sizes and scale to produce oil and gas. And so on the left, you just see a couple of the big ones. On the right, these are oil majors. They're often integrated in that they maybe own midstream assets. They maybe own refinery capacity as well. And these are the big names that you would really know. And some of them are if not currently, historically are state-owned or state-managed or have some relationship with the government in which they operate. And so the bigger ones, like Exxon, to get exposure to U.S. onshore, has purchased a couple of the E&P companies that you would normally see on the left side of the slide. So Pioneer would be an example. And so there's been industry consolidation where larger oil and gas companies are acquiring mid-sized and smaller oil and gas companies to get exposure to the assets that they own. Okay, midstream. This is how do we get this stuff from one place to another. Pipelines are a major way of doing it. So they operate these pipelines and they build these pipelines and they help get the oil and gas from one area to another. Then there's LNG, which has become very popular lately, and there's lots of growing LNG facilities being built, especially in Europe and in the U.S. and in Asia as well, because it's a great way to transport natural gas, which doesn't transport very easily. And then you have shipping, which is like oil and gas tankers that are filled up at a port and then delivered to another location where they are needed. These are very important pieces of the puzzle that we're seeing in the global dynamic today with geopolitical issues. How do you can the midstream, if you can slow down the midstream or make it difficult to transport, the price of the commodity goes, it creates a supply dynamic where the price of the commodity increases in reaction to that difficulty in transporting hydrocarbons. And so there's another piece of this too that I don't have a slide, but something that's kind of tangentially related to midstream is how do you handle the waste? The waste that's produced from all of these facilities. That this isn't like just trash that you can throw away. You have to handle it. It's highly regulated, and so there's kind of a waste management component to midstream, and that's related. There's a lot of produced water. When you drill a well, you get water. You oftentimes get natural gas as well, natural gas liquids as well as oil. So how do you handle this nasty, brackish water and manage it is also another piece kind of related to midstream. And we're seeing that some public companies in the U.S., some companies go public in the U.S. related to waste and water in the oil and gas space. Downstream. So this is traditionally kind of viewed somewhat limited in terms of refining and marketing of refined products and kind of retail gas stations. And this is the type of place where you go fill up a car. That's kind of the downstream view. I think it's important to maybe expand that thinking just a touch and include commercial uses such as natural gas power plants to create electricity, airlines, airports for jet fuel and refueling, that kind of transportation. There are military and government uses that are downstream. The manufacturing, as we said, of like industrial lubricants and lubricants in general, which allow the world and metal to move. There are plastics involved, the manufacturing and production of plastics through petrochemicals. And then just thinking broadly about all of the uses in terms of clothing, like your athletic wear often has some sort of chemicals related to petroleum products. Food, fertilizers have some relation to oil and gas. Medical uses, does manufacturing of medicines use petrochemicals? Cosmetics have petrochemicals. Building materials. The list goes on and on and on about how it is involved in your everyday life that you maybe don't even realize. And there are opportunities consistently everywhere along this entire supply chain to add value or to consume these products in new and unique ways. So now that we've done upstream, midstream, downstream of the oil and gas place, there are also service providers and things that are related to this broader industry, and we're going to talk just briefly about those as well. So there's oil field services companies. These are names that you probably maybe have heard of. They are big, huge multinational corporations. These companies help the upstream companies drill wells, find wells, manage supply chain, which is like buying steel, all kinds of other things. They have technology platforms. They acquire technology platforms. So for me, where I invest in software businesses for the energy sector, these companies could or do look at acquiring the companies we invest in. So SLB, formerly Schlumberger, Baker Hughes, Halliburton, there are many, many more, and there are thousands of them, just small businesses that exist to offer services to the energy sector broadly, but these are some of the big ones, and there are, I think in the U.S., I was looking at a list once, there are well over 30,000 service providers that help the industry operate, and there are huge opportunities there for both digital use, and these can be very simple things such as accounting platforms, billing platforms, general just business platforms to help these companies operate and service their clients, which are the oil and gas industry. And then there's engineering and equipment providers. So how do you build engineering plans? There are huge global engineering firms to build. Some of this is the biggest infrastructure, the most complex infrastructure in the world. And so there are huge engineering firms that help and get hired as consultants to help build multi-year projects. You don't just build a pipeline and by slapping pipe together. There are engineering and planning and equipment providers that help make that possible. And here are just some of the larger global ones that exist as well. How do you drill how do you drill offshore drilling rigs and manage those? How do you get the steel that you need? What kind of steel do you need that can handle the pressures and temperatures that are required? Those kinds of things. Okay. This is where I'm focused. I think the focus of the conversation from here on out will kind of naturally gravitate towards, which is that digital layer and that software layer to help energy industry become more efficient, to deliver cleaner, safer, more energy, to deliver higher profit margins, those types of things. And here are just some logos, some that you will notice, like Palantir. These are C3 AI. These are migrating to being very AI focused. Because I think it's difficult to not have an AI component at this point or be thinking in that way if you are a digital provider to the energy sector. And so there are some big ones here. There are some of my portfolio companies here. AI Driller is a drilling platform that we're invested in. IronIQ is a SCADA, which is a data gathering component. If you think about digital transformation and AI, you have to start getting clean data from dirty places. You have to start cleaning that data, processing that data, determining how you're going to apply that data. That whole data management layer doesn't exist in many industries, especially industrial sectors. And there's a huge, in my view, opportunity to start better managing data. These industries are digital laggards in that regard, and they're linking really the physical world to the digital world. And phase one has only really been the digital world and applying digital tools or AI to the digital world. These are things that are naturally or are already in digital formats, and this doesn't exist in the industrial sectors. They are massive digital laggards. So before you can really apply AI broadly, you have to have that digital layer and manage the digital layer so that you can start using it for higher use things such as automation, which is the macro trend, I believe, for the rest of my lifetime, of which AI is a sub-trend. But it is really, increasing productivity and doing more with less.
Can you stop for a second on this slide?
Yes.
And I have a couple of questions. What kind of data, like as an examples, like now, like not managed well in this industry? Just few examples.
Sure. So let's just say you have a well. It sits out in a remote location. Getting data from that well, like what are the pressures? What are the flows? How much flow is coming through the pipes? Those are old analog. In many cases, they are old and analog meters that somebody used to walk by with a clipboard every day at a certain time and write down the number. And or you have somebody whose job it is to watch those things, but there's no analytical component of it. And so making these meters digital, for example, is a great way to start gathering, say, second by second data. There's lots of variations in things. And you may have a spike in pressure that you don't capture when someone looks at it twice a day. And so those are some examples of where gathering the data to just suddenly be able to process it can be hugely advantageous to making adjustments. There are numerous uses for like temperature data. What is the temperature outside? What is the temperature within the facility? Sometimes they don't even know these things.
And so, as I understood, there are some data already exist, but they're just not gathering it and not doing analytics on that.
Yeah, and then here's the other component too. Like there are rules and regulations. Are you writing those by hand? Are you filling out paperwork by hand, or can it auto populate? Because now it's in a naturally digital format. Because somebody entered the data when they had to manually. They entered the data in on, say, an iPad, so it was naturally digital instead of on a piece of paper that went back to the office and over the next 10 days gets digitally entered or never gets digitally entered and gets put into a file cabinet. So you can auto-populate things, making things more efficient. You can auto-send alerts. You can send somebody out when something breaks. Macademy, it sits on, you'll see it, that's that it's that lower logo that is kind of a neon green on blue. They exist for LNG facilities to help manage the machinery, turbo machinery that exists at these facilities to help them better expect maintenance, better manage the hardware to reduce when it goes down and breaks. Because when these facilities go down because something's broken, that costs a huge sum of money. So things like that as well.
So it looks like a lot of business processes inside the industry which could be digitalized, including AI, and each one, even one process could, like save a lot of money or for the company, and it was to try it.
Yes, absolutely. And it's the analogy, I don't know if you've ever heard this, but the question is, how do you eat an elephant, right? And the answer is one bite at a time. And the digital transformation of the energy sector is an elephant. And so how do you solve the problem? And it's one bite at a time. These are small little pieces that will interact to create a digital energy company.
Yeah, we were talking at last session with one startup. They're actually solving a problem also for energy sector and just digitalizing, reading the one PDF document, which is one of the like most important one, which cause a lot of like troubles and a lot of other like processes, a lot of cost, because they cannot read it right away, and it just manually even not updated. It just kind of like another how I say, it's like one document, and after that it's just like not another version. It just kind of appendix, what changed and it's like always changing, and after that you need to look at a lot of like papers to have a like picture what happened. And it's about pipes, also pipelines. And when they like did the solution, made a solution. It's Kazakh startup, actually, Kazakh guys. Recently, they were chosen by a few American companies, like to try that solution. And just one paper, actually. They digitalize how to read in it, and just like how to like work with that in the future, because it's solving a lot of issues and saving a lot of cost. Just one format, one template. So, and one more question about this slide also. Can you tell a little bit about a couple of these startups? What are they doing? I think firstly Palantir, because it's maybe one of the biggest here and most famous, but maybe our students, I'm not sure that everybody knows this company, but it's very interesting. Can you tell what they're doing for this energy sector?
Yeah, so Palantir is a huge corporation now, focused on basically AI for all different sectors. One of their original, the way that they got going, and one of their original backers was British Petroleum. And British Petroleum is using them and integrating Palantir to help automate processes, to help gather data, to structure that data so it can then be accessed. For example, and I'm not sure exactly how they're using Palantir, but one use case for it would be in oil and gas. There's huge amounts of data that isn't used. And one of the examples is like geological data, subsurface data. It is difficult to process. It's intensive. It's very detailed. How do you search all of your geographic data to maybe gain new insights about where to drill, how to improve decision making, those types of things. And Palantir probably, I'm highly confident, has a role to play in how they are starting to think about it, and starting to improve their decision making, and being able to analyze some of the huge amounts of data that exist that go unused.
And in which company did you invest from this slide?
On this slide, I have 3 of my portfolio companies on this slide. Iron IQ is a SCADA company. They are replacing a very bad software that exists. It's a good example of improving software that already exists in the industry. It's called Signet, is the software they are replacing. It is owned by a company called Weatherford. It is a software that was originally built for the nuclear industry in the early 90s. And once the nuclear industry kind of got was slowing down, they shifted over to oil and gas. It is a antiquated software. It is a horrible software structurally. It is something that was built 35, 40 years ago now. And Iron IQ said this software exists in the marketplace, is a bad option for the industry. The industry needs a modern software. And so Iron IQ created that modern software to replace this old legacy clunky software. AI Driller is another company. They are a drilling software that sits at the drilling rig to better manage and better make decisions and automate decision making at the drilling site while drilling. And they are expanding horizontally as well to capture completions, management of a drilling of a well once it's been completed and is producing, and then all the way to end of life for a well. So it's one of those pieces where if you're gathering data at the birth of a well, you can expand far better. You can expand even earlier, which is the planning of the well, and you're gathering data throughout the entire process in a structured format. So that's what they are doing. They are on about 300 wells, 300 drilling rigs across the world, and they are doing well. And then Academy, as I said, is another investment of ours. They are on LNG facilities primarily, is where they started. but they are focused on turbo machinery and holistic views around that machinery in order to better manage the turbo machinery, which is vital for the operations of an LNG facility. But turbo machinery exists all over the place. It exists in midstream, in compressor stations, and turbo machinery exists in natural gas power plants as well, managing the turbo machinery there. So there's lots of applications to what they do, and they are doing well as well. I have a number of other companies. We've exited a company to Enverus. Enverus is on this slide. Enverus is a large energy technology company. They were just acquired by Blackstone, which is a huge private equity firm, for I think $6 billion. I'd have to go check. And then Quorum is another. They were just acquired by a private equity firm for I think $1.5 billion US. They have a number of software solutions for the energy sector, as well as Peloton is in that category as well.
And last question about the oil and gas companies from this, like traditional energy. Do they feel like this demand, like to digitalize the data, to, like to do innovation inside the companies? If yes, so where are the strongest demands? Operation efficiency, asset uptime, predictive maintenance, or something else?
Yeah. So one of the opportunities at a macro level in oil and gas specifically is oil and gas has a demographic problem of employees, especially in the U.S. And what I mean by that is there were a number of employees in the 80s, so you can see this through petroleum engineering degrees, for example. And then the industry laid off a bunch of people for a long period of time around the world, and then it spiked again, and we've now fallen off. So there's a demographic gap. Many of the senior people are, I will say, over 55. And or retired already, and many of the other, and there's nobody in their 40s, and then there's a bunch of people in their late 30s, early 40s that are younger, and so it creates a demographic difference in the energy sector. The older generation, they don't believe in as many digital tools, let's say. Okay. They are less receptive to doing things in a new way, to changing a process, for example, to implementing a digital tool. They don't see as much value from it. The younger generation, on the other hand, is digital native, and they see a huge desire for digital tools. So that's a dynamic that's going on. And then you look at the mindset of the energy sector in general is run by engineers, and an engineering mindset is zero risk. They're not interested in taking any chances, which is fabulous, by the way. If you're building bridges, buildings, or wells, you don't want those things to fall down or break. You want zero risk. Digital tools, though, the cost of failure is actually very low in many cases. And so it's easy to adopt things and try things out and then go, this didn't work, so we're going to go do other things. That mindset is starting to change as well. And so where are the biggest opportunities? Well, I think that there are huge opportunities in terms of just business general process. Replacing legacy accounting systems, replacing legacy SCADA systems, but the adoption just isn't quite there yet. The industry doesn't want to adopt new tools for some of the reasons that I just described. And so the better places are places where, in my view, there is no technology, or very little technology. And so procurement, how do you buy, how do you responsibly acquire the steel that you need out in the field? What's reducing costs, managing those costs? I think there's great opportunities there. Things related to the production on the revenue producing side of the equation versus the operation side. The revenue producing side is like AI Driller, where you're drilling a well, you're generating revenue. Those are places where technology and adoption of technology is more incentivized than the operations side, which is that business process side. So there's where I see some opportunities.
Thank you. Let's move on then.
Okay, energy transition is what everybody talks about. It is the number one topic as it relates to energy. And so I'm going to just talk very, very briefly and provide some insights around it that are more macro versus diving into like a true market map because it's still evolving. We saw this slide earlier, and the energy transition is a shift from burning things on what is to me the left, and then going over to things that are more manufactured or less burning that don't produce CO2. And so you see that most of the things on the right go to electricity. They don't go to transport, and for the most part, they don't go to heat. Like solar has a heat component, obviously, but it's very, very teeny. So we're being intellectually honest here, if not practical. Okay, but on the left, you have all these things that we burn, and this is how humanity has generated energy for its entire existence: biomass, dung, wood, natural gas, oil, coal, etc. And these can be used, oil particularly, for transportation. And so what we see here is we're trying to get rid of the left side, which makes up 80 to 90% of our energy consumption, and we're trying to switch it all over to the right side. But not only are we trying to do that, all of this, because of look where all the arrows point to, they point to electricity. We're trying to electrify everything. Electric vehicles, electric steel, electric cement, electric everything. And so how do you do that where you send everything to electricity and then you run all your transportation and all your heat, industrial heat in particular, through electricity? That's a really big challenge, and it's a massive shift. And it is a shift that, like, there are lots of uncertainties about it. And that disruption creates gaps and fractures things within an industry, and the largest industry in the world. So energy transition, as I said, means electrify everything. And that is a big trend in terms of being able to move electricity around. So power distribution, the power lines, there are plenty of digital technology solutions that can be applied to simply moving more electricity over the power lines that exist. How do you handle increased complexity within the electric grid, from going from a centralized production, say a natural gas power plant or a nuclear facility, to a centralized map with decentralized production, which would be the solar power panels on, say, your house. That's tied into the grid. That creates huge amounts of forecasting complexity and huge amounts of complexity among the system. So you need new sensors to be able to understand where demand is coming from, what demand's going to look like, and then how you're going to get it there instantaneously and what you're going to use, because you can't send too much. You can't send too little. You have to match demand with supply almost instantaneously when you're talking about electricity. And the demand could shift drastically just with people charging EVs. If everybody in your neighborhood is charging an EV at their house, that's a totally different demand profile than it was previously for everybody went home from work and ran the dishwasher or turned on their electric heat. It's a massive shift. And that creates new demand for new infrastructure, new sensors, new information, new analytics. It's just a huge opportunity. New billing, possibly. Different types of billings. And that's that electricity power gen, which is the generation, which is solar, wind, nuclear, and currently based on hydrocarbons. And those also are variable. Okay? Wind energy only produces when it's windy, solar only when it's sunny. They don't store electricity, so you have to have some way of storing it, which creates a huge demand for batteries in order to have reliability, because the grid doesn't do well with high variation of production. And so you have to figure out all of these different complex elements that AI has a great, and digital tools are really very useful for. And so I think there's going to be huge opportunities in power gen and power distribution. And we are investing aggressively in this space and looking at things that are digital tools for the energy transition, digital tools specifically for power gen, power distribution, and management of these new facilities. Right now, this is the thing too, electricity is a very small part of general energy consumption. It is somewhat difficult to manage electricity. It needs to be consumed when delivered. It doesn't store energy very well at all. Like coal, one of the big reasons why coal is demand is increasing, it is a wonderful store of that energy. You have coal, you dig it up, you put it next to your power plant, it can sit there for 1,000 years, but when you need it, you can burn it. Okay, electricity is not that way. And then another piece. So this is when you read about energy and electricity, when you think about it as well, one of the big problems is that people confuse electricity and energy. And so they will talk about how Germany produced 100% of its energy from solar and wind. They'll make statements like that, which are factually inaccurate. Germany may have, for a period of time, produced 100% of its electricity from solar and wind. And that is still a very small percentage. Electricity is a small percentage of the total energy consumption. Okay? So something to think about when you're reading these things and to understand that can oftentimes be misleading. One of the opportunities, and these are all complexities and structural things that create opportunities in energy or in electricity and power gen and power distribution, if you can understand them, is there are different regulatory regimes and incentives and policies that distort the market. For example, in the US, the way the regulated electricity providers were originally incentivized to produce was they get paid roughly 9% of the amount of money they spend on new infrastructure. They don't get profitability. They don't have profitability incentives. They have spending incentives. So if you're going to sell technology to them, it has to be something that their regulator will allow them to spend the money on and get paid on. So totally different incentive from a normal business. There are market force dynamics. There are political dynamics that change the incentive structures. There are through data centers and also the electrify everything trend, through the energy transition trend, as well as the world wants cleaner, safer, more energy. We've failed to deliver electricity to a vast part of the world. So there are huge demand pieces globally for electricity. They're just massive. But supply is somewhat slow to react. It's hot. It's big infrastructure in many ways. If it's solar panels, it's manufacturing capacity and mineral capacity. So that creates opportunities, especially for digital, to maybe help close that structural supply-demand gap. As you know from economics, when supply-demand gaps occur, price is the only mechanism outside of government intervention for that to be reflected. And so when there's more quantity demanded than there is supply, price goes up in a natural free market. Okay, you have changing business models. These behind the meter production that is very disruptive to what electricity is. So that would be the solar panel on your house. That could be for a data center bringing its own power generation, creating its own natural gas power plant to supply electricity for how it operates. That's behind the meter is what it's called. It doesn't get metered. It's not attached to the grid. Totally different business models, totally different needs, big planning incentives. How do you buy these things? Supply chain issues. There's a lot of opportunities here. Volatility and reliability, we've talked about how they fight each other. If you want a reliable grid, you don't want volatility. And so how do you fix those two items and bring them back in line, kind of like supply and demand, and then shifts in how power gen is generated, and then supply chain difficulties. There's huge opportunities in electricity, and there are massive tailwinds that exist. So I would urge people to take a look at this space and really understand it and come up with ideas here, because it is a very, very big opportunity. Okay, and this is the dirty fact about energy transition. Energy transition is a transition from hydrocarbons, oil and gas, and also coal, and the left side of that chart that I showed you where we burn things, to the right side. But it is a transition not to solar, but to mining. Solar panels, wind, other things, nuclear, they all require metal and mined material. And so if you look at the EIA forecast, which is a large energy forecasting group with tons of data, it's wonderful for you to go take a look at that if you want data. There's the IEA and the EIA in the US, and there's plenty of energy groups out there that produce all kinds of data. The big oil majors produce all kinds of data. they forecast a massive need in mining. Like we're talking like 10x the amount of uranium, cobalt, lithium, nickel, aluminum, all of these base metals that are required in a huge way to manufacture wind and solar and nuclear. That is mining. If you look and read about mining does, if you think that there's a supply demand imbalance, or it's hard for supply to come online for other energy components, mining is incredibly slow. It can take 10, 20 years for a new mine to come online, especially in the West. And so how are we going to meet this demand, this huge increase in demand for these minerals? So I would urge you to add mining to your thinking of energy. As we talked about at the beginning, think broadly about what energy is, and think, and this is one example, expand your thinking to mining. And so there's a great opportunity there. We've invested in a mining tech company that is UK based, that is focused on the mining sector and helping the miners better find new deposits. So finally, AI and digital tools are likely to play a major role in the energy sector's future to help close supply-demand gaps, to help close volatility reliability gaps, to help manage the industry operationally, to help find new resources to meet those demands. It just is a huge opportunity, and this industry across the board is a major digital laggard relative to other industries. They are not nearly as digitally advanced. And so I'll end there.
Thank you very much, David. I have now a few questions to like finalize. One is, for now we have like 80 to 90% still oil and gas, traditional oil and gas companies, a big infrastructure, and they all have some, like opportunities inside. There are maybe some people are old now, don't, like want to change anything. And there is a small percentage of the market of like this renewable energy, but it looks like it's growing sector. Where, in your view, it's like more opportunities to easier to enter for startup, like old traditional or like new one, a new industry, maybe like both, and why?
So I think it is easier as a startup to have a product where you're not competing with existing products, so the company doesn't have to rip out an existing product to deploy your product. And so that's a better opportunity or speed to market that than forcing an energy or any business. This is just true across the board. If I have to rip out my email product that I'm using in order to use yours, the sale becomes far more difficult, and the time to sale is far longer, and the decision-making framework is different. So that's something that I think, if you're looking at an opportunity, you should think about. Where I see specific opportunities, I mean, these industries are such huge digital laggards that there are opportunities across the board. There are opportunities for an upstream, midstream, downstream, for better understanding the assets, the physical assets that they own and operate. There are business opportunities to, I'm going to preface this statement with this. People don't want to say this, and I don't fundamentally understand why, frankly, which is, you have two choices when you get productivity gains from software and automation and AI. You can produce more, you can do more with less people, or you can let people go. People say this is the downside of AI, and if you're the one being let go, yes, I agree with that. But at a macro level, that is technological advancement. It is what happened during the Industrial Revolution. Luddites were a group of people that fought industrial machinery, and I can tell you right now, our world is massively better because of the Industrial Revolution. And I think, optimistically, that is the opportunity with AI and automation, okay? And so you can choose to do one of those two things. And so I think that's the savings of AI and software. So I would look for places that have excess headcount, too many people, people doing tasks that are better suited to AI or better suited to automation. And to start with, that is things that are data heavy, that require someone to format data before they can do the analytical work. Here's an example. You're paying somebody $500,000 a year, US, to be a petroleum engineer. He's a senior petroleum engineer, he or she. And they're getting a lot of money. And they spend sometimes, when you talk to them, 60% of their time trying to format data so they can use their head to analyze the data. That's a great use of AI. That's a great use of automated process to grab the data, structure the data, so that way they can make better decisions. And I would look at processes like that. So you're not getting rid of that expensive. In fact, it's probably worth more to hire that person now. You can afford to pay that person even more because they are spending more of their time, but they're more productive, spending more of their time using their brain, analyzing things and making decisions instead of formatting data.
So, as I understood, it's like a lot of opportunities in all traditional oil and gas companies, and also a new, like solar or wind, like renewable energy companies. It doesn't matter where to go.
It's like how do you plan a solar farm? Where do you put it? How do you do the land entitlement? What's the paperwork and the legal work around that? What is the true forecast of the productivity of that? And are you going to be curtailed, which is when the power distribution company says, hey, listen, we can't take your solar. You can't put it on the grid. We are not buying it. In fact, you got to figure out something else to do with it. So what's the curtailment going to look like? All of those forecasts, those change your economics and your economic models. So planning those things, it becomes really relevant. Supply chain management, how are you going to maintain those? Billing, how are you going to bill? How are you going to distribute, if you have investors, how are you going to distribute the profits? You need software for all of those things. That doesn't exist in many ways.
Yeah. And another question is how to approach, like this market, because it's actually these solutions for energy companies, it's kind of like capital intensive anyway. And we have some industries where it's also capital intensive. And we were talking with other speakers how to startups can approach, and it was few suggestions. One is like to start from some maybe simple business process, like for example, like administrative business process, which still consume time, But after that, gathering some data and, like build layer by layer. It's one of our speaker told about healthcare, for example, because it's really regulated, and in order to start something, you need to, like invest a lot. Another speaker said that from mining industry, how to approach mining industry, it's like to get partnerships. For example, to go with some partners, these service providers, to get, for example, with cooperation with Shell, you can approach his service provider or some consultancy, and offer the product to them and sell together. So maybe you also like offer your way, maybe add something, how to approach this market, how to enter without, like very big, the round to raise.
There's a famous book called The Innovator's Dilemma. It's written by Christensen. I would urge you to go and read that and better think about your technology and where it sits. Okay, that's one. And the other is this: you in industries that have big, huge corporations, you're highly unlikely to be able to sell your innovation to Shell if you have existed for less than 10 years, okay? And you don't want to, because just their procurement process, their legal, this could take hundreds of thousands of dollars and years to just get through the process to be able to sell them a product. So you really need to think strategically about who are the early adopters of your technology and who talk to them, get their feedback, understand what their needs are, and realize that you don't know what you don't know, and you need to go and learn these things from the people who live in the trenches. An example of this is as follows. We're invested in a company. The founder had an idea. He had worked in the industry for a few years, which is something that you have to do, and this is an example of this. He had worked in the industry for a few years. He had an idea for a company. He decided to go to a very blue collar, which in the U.S. language, that means like a very like going and getting your hands dirty. Okay, like
Yeah,
a
we
plumber.
also have this
Yeah.
term.
Okay. Okay. So a very blue collar industry, which is trucking and waste and dealing with waste. So trash, basically. And he went and spent time, 2 years, learning that industry from the inside as a very low level employee and observing what goes on in that industry. He made contacts, he made friends, he came up with ideas, he refined his idea, and then he launched his company. But he had industry experience, he had the idea, he went and lived it and experienced it. He developed a contact list, a network list, and understood the players and created his market map. He knew who he was going to call, who he was going to interact with first, then second, then third, and the different industry groups that he needs to navigate over the years of his business as he develops his technology. And it takes that kind of level of commitment and knowledge and time learning things before you can really launch a company in industries that are highly complex and have dynamic needs. So, and he is only now, probably I'm going to guess he's 7 years in, talking to major companies and having an opportunity to at least pitch them on his product. So that's kind of the length that it takes in these legacy industries. It is not fast for the most part.
But it was at the end, I think, the result, because it's like really not a lot of competitors there, actually. Not all of startups are ready to go through this, like way. But another question to this point, but what do you think about the venture arms that now Shell, Chevron, like Saudi Aramco, all big, like players they are building now, and actually it's even for, like early startups, they already have written all problems and they just give it, just come sit, like this is the problem, just like try to, like solve it. If you solve it, after that we will, like see how to, like operate in the future. What do you think about these opportunities?
In what way? Like are they like what opportunity with the venture arms? Like taking capital from them?
It's like to create solution. Is it really helpful to get some experience to,
Oh yeah.
like in building solutions, maybe, like after that to cooperate, maybe like to get capital, in many ways.
Yeah, so I work with all those corporate venture arms, and they are the smartest and best people I've ever worked with. Okay, now that I said that,
Great. So
I
insights.
yeah.
Insights.
Yeah. So if any of you listen, you are the smartest and best people I've ever worked with. I think that's a great opportunity if you could go work for them, to go and work for them and gain experience and see what's in the market. It's a fabulous place to be and understand you sit in a very unique position, which is the corporation on the inside is telling you we want this, and then you're going out into the real world and outside of the corporation and trying to find this. And so I think that puts you in a very unique experience. Those roles, though, are, from my understanding and my perspective, very few and very difficult to get, and they are usually brought from internal. But I could be wrong there. So one, yeah, if you could get a seat at that table, that would be a great table to sit at from an experience perspective. From a getting capital from them and their programs, again, these are big corporations, and they are not looking. Those corporate venture groups, for the most part, are looking for things to invest in at a much later stage than say when I invest, because the technology needs to be mostly developed, and there needs to be numerous reference clients that have existed for multiples of years. So those corporate venture groups, for the most part, are not looking at early stage businesses. They have programs, however, Chevron and Shell that are very early stage, that they just write you $100,000 grants. So it's non-dilutive
Yeah.
capital. You go through the program, you learn about the sector a little bit, you learn about how to interact with Shell, what they're looking for, but they are not looking at that point, for the most part, they are not looking to deploy your technology, nor are they looking to write a big check to you. They are giving you $100,000 non-dilutive to develop your technology and maybe migrate over the years and keep their eye on you, but that's the objective.
Yeah, this is actually like my question about this, like activity, about these incubators. It's not a big check, yes, 100,000, as I heard also. But is it how difficult to get there to this incubator? I mean, like to get this 100,000,
I think
if
it's
you
it's
know.
hard to say how difficult. I think that you should absolutely apply and use those groups as a resource. You absolutely should. That being said, you need to have things pretty uh, 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 detailed and ready to go. Do not go to them with some half-baked idea and poorly created investor deck. I think you need to be pretty advanced and pretty special before you go and talk to them.
Okay.
Because
So,
once you talk to these people, you only get one shot. That's true
yeah.
with everything. Like for fundraising and everything. Don't go to your highest and best first. Go to people that are maybe unlikely to invest and maybe aren't important to you from like I don't care if this person invests at all because it allows you to gain experience and to test your pitch and to get feedback and to understand and do that a bunch of times before you go to say your highest and best, which may as well, let's just say it's Chevron. Before you go there and apply, make sure that you have talked with a lot of people beforehand and gotten feedback and revised your investor deck and your business plan and your ideas. You don't want to be going them with a fresh baked idea. For example, for me, for my investment fund, I have probably 200 different versions of an investor deck that has improved every time I talk to people and I get feedback.
Okay. So thank you very much, David. Actually, I don't have questions anymore. Thank you for coming to our program second time, and it was, I think, for me, a really, like informative session where I personally also will see one more time again. I will watch to, like understand the trends. And maybe you want to say something like finally.
Yeah, it's been a pleasure to speak here. I'm honored that you want to listen to me. But I think the energy sector and industrial sectors in general create some of the biggest opportunities over the course of my lifetime. And there are urgent human needs for these sectors, especially energy, to develop digital tools and digital technologies. And that urgency creates massive tailwinds over the long term for anybody looking to solve the problems here. And that is a great thing to do with your life, to spend your life trying to solve some of these problems. And it is potentially very lucrative for you to solve these problems because if you do, the rewards are massive or potentially massive. So I would urge you to take a look if you are inclined and have interest in these sectors to really figure out how we can improve the world around us.
Yeah, thank you very much. It's very actual for us because Kazakhstan is, first of all, it's like a lot of oil and gas, a lot of, like materials, potential for mining, what we don't do right now. We have first place in uranium, for example, in the world. So, and it's a lot of companies what you like mentioned. They are presented in Kazakhstan with operations and representatives. Our students actually have access to them. They're open to talk, like discuss solutions. And I think that it's a good opportunity in our country to, like we have opportunity to go and we have to use it. This is like also my point for students. And thank you very much for watching us. So David, bye, and bye everybody.